Okay, class, picking up where we left off at. We have the Martellos traveled 1,276 miles from their home in Springfield, Missouri to Yellowstone National Park. If their trip took 19.9 hours of driving time, estimate the average speed in miles per hour that their car traveled. Okay, first of all, let's do this. This is the total distance that they traveled, 1,276 miles. Now, my suggestion would be to do this. Let's round to the hundredths place. So we know 2 is in the hundredths place. So we'll look to the right at the 7, and that would take this to 1,300. So that's 1,300 miles. Now, we come down here. We want to do miles per hour. We have 19.9 hours. I would suggest that we round to the nearest hour. So we would be rounding to the ones place. So we look to the right of this 9. We have a 9. So we have to add 1 here, which will make this 10, which make us add 1 here as well. So this would be 20 hours. So now, this is what we would need to do. We would have 1,300 miles divided by 20 hours, because it's miles per hour. The word per means division. 1,300 divided by 20 will give us 150 miles per hour. You could write 150 mph, or you could write 150 miles over 1 hour, or an hour. So this is our approximate answer, so we should do this as an approximation sign. Okay, now we have B. If their car used 52 gallons of gasoline, estimate the average gas mileage of their car in miles per gallon. First of all, we already have our miles estimated at 1,300. Now we have to deal with our gallons here. Since this is a 2-digit number here, I would suggest that we round to the tens place. So the 5 is in the tens place. We look to the right. We have a 2. And we know that that will become 50. So it would be 50 gallons. Okay, so now we would take our 1,300 miles. Because remember, we're doing miles per gallon. And we would divide it by our 50 gallons. Now when we divide this here, we would end up with 26 miles per gallon mpg, or you could write 26 miles per gallon. And remember, per means division. So now we scroll down here to C. If the cost of gasoline averaged $3.51 per gallon, estimate the total cost of the gasoline used. Now I think to make this a lot easier, let's round to the nearest dollar amount. If we look here at the dollars, which is 3 is in the dollar amount, or the ones place, and we look to the right, we have 5. So this will round to approximately $4. It says estimate the total cost of gasoline used. Now we need to go back here. Now, if you look here, remember it was said that the car used 52 gallons of gasoline, and we rounded it to 50 gallons. So what we would need to do is to take 50, which is how many gallons of gasoline, approximately how many gallons of gasoline that was used, and multiply it by $4. 50 times 4 we know is 200, so it'll be $200. Now, we can write this like we did in the earlier example. We will have 50 gallons multiplied by, we had approximately $4 per 1 gallon. And we could put this over 1. Our gallons will simplify out, and 50 times 4, we know that would give us approximately $200, which is the same answer we have here. So either method is acceptable. Now we move on to the next activity here, which is estimation with graphs, and we're dealing with the circle graph. Example, applying estimation techniques to a circle graph. Circle graphs or pie charts use a circle to represent the whole and divide it into sectors proportional to their part of the whole. The circle graph below indicates how Americans disagree as to when old age begins. Okay, this is the pie chart. It says 32%, which is a much larger piece of this circle compared to this 9% or 3%. You notice that 41% is the largest, 32, 14, 9, 3, and 1. It's proportional to their percentage. Now, if we look here, we have different sections. We have decline in physical ability, decline in mental functioning, reaching a specific age, don't know, retirement, becoming a grandparent. Those are the various reasons. Now it says, according to the U.S. Census Bureau, in 2008, there were 220,948,915 Americans 20 years and older. Assuming the circle graph is representative of this age group, determine a calculation that shows the number of Americans 20 years and older who define old age by a decline in physical ability. Now, if we go back up here to the circle graph, that's 41%. So they want us to approximate this. So first of all, let's take a look at what it would look like if we wrote it out without estimating. So first of all, we know 41% feel that a decline in physical ability defines old age. So we would take 0.41 and we will multiply it by the amount of Americans 20 years and older, which is 220,948,915. Now, this would be a little bit more difficult to multiply without estimating if we were not using a calculator. So let's imagine we're not using a calculator and let's approximate. Now this 0.41, which is representative of 41%, we will round to the tenths place. So we'll look here, the 4 is in the tenths place. We look to the right of it, it's a 1. So the 4 remains the same. And we'll drop everything behind the 4. So that'd be 0.4. And we will multiply here. Now, since we have 220 million, it seems that we should round to the millions place, which is this 0 here. So we'll look at this 0, we'll go to the right of it. This is 9, so this is 5 or more. So we will add 1 to this 0 and make everything behind it zeros. So it'll be 221 million. So we have 0.4 times 221 million. Now, actually, to make a little correction here, instead of rounding to the millions place, we probably should have rounded to the 10 millions place, because if we're only dealing with 2 digits and the rest zeros, that would be easier than dealing with 3 digits and then the rest being 0. So here we have the 10 millions, which is this 2, and we look to the right of it is 0. So that would give us 220 million. So we need to make that 1 a 0. So we would take 0.4 times 220 million, and that would give us 88 million. So our answer basically is approximately 88 million Americans 20 years and older define old age by a decline in physical ability. Okay, now it says use rounding to find a reasonable estimate. Okay, class, actually we did A and B with this question here. Actually, A was this portion here. This was actually the calculation. And then B, when we use rounding, it's these values here. So this actually, what you need to do in your notes is write this in for B, and this would be your A here. So now, we scroll down to estimation with graphs. Bar graph. Bar graphs are convenient for showing comparisons among items. Bar graphs use a vertical or horizontal bar to represent each item. The heights or lengths of the bars are used to show the amounts of different items. We can use bar graphs to make predictions. Example, applying estimation techniques to data in a bar graph. The bar graph below shows the life expectancy for American men and American women born in various years from 1960 to 2005. It says use the data for men in the bar graph to estimate each of the following. It says A, estimate a man's increased life expectancy rounded to the nearest hundredth of a year for each future birth year. So we would take 2005 total of life expectancy for a man, which is 75.2, and we would subtract 1960s, which is 66.6. And we would divide this by the years that we're counting, which is 2005 minus 1960. Now, after we subtract this, we would get 8.6 all over 45. Now, when you put this in your calculator, this will give you approximately, because we're rounded to the nearest hundredths, it will give you approximately 0.19. And that will be your final answer. So it's just basically saying that for each subsequent year after 2005, or starting with 1960 to 2005, every year after that, men should see an increase in life expectancy by 0.19. Okay, now B. It says estimate the life expectancy of a man born in 2020. So what we would do is we would take the value from 1960, which is 66.6, and then we would add this approximate value we have here, which is 0.19, because that is the approximate life expectancy each year after 1960, which would be 0.19, and we will multiply it by the difference of 2020 and 1960, which would be 60. Because remember, we're going to 2020 from 1960, and we would subtract, we would get 60. So now, we will multiply and then add 66.6. So we add 66.6 plus 11.4, and that equals 78. So a man born in 2020 has an expected life expectancy of 78 years old, approximately. Now we have estimation with graphs, line graphs. Line graphs illustrate trends over time. Some measure of time, such as months or years, frequently appears on the horizontal axis. Amounts such as age or percentages are generally listed on the vertical axis. Points are drawn to represent the given information. The graph is formed by connecting the points with line segments. The line graph below shows the average age at which women in the United States married for the first time from 1890 through 2007. The years are listed on the horizontal axis and the ages are listed on the vertical axis. The jag symbol seen here on the vertical axis, you see this here, shows that there is a break in the values between 0 and 20. Thus, the first tick mark on the vertical axis represents an average age of 20.